ciao, come bene? Oh, wow, I also have Rene, and I have Roy, I have Luigi. Nice to meet you, Luigi, for the first time. I hope everybody has drank a lot of coffee. I don't know, you notice I drank my share of coffee. And I'm fully full of energies for this afternoon. We are touching a really interesting topic, the topic of blue and UV lasers. We have companies that are users in the energy sector, like ENEA. We have users in the defense sector, like DSTL. We have integrators that actually integrate blue lasers in other laser systems, like Noburu. We have the whole entire supply chain all the way to the optics, and you're going to learn about the Axicons from Roy from PowerPhotonic in Glasgow. It's quite spectacular what they do there. So let's get the thing started. Ladies and gentlemen, welcome. Welcome to the epic meeting on UV and laser diodes. My name is Jose, and I look really, really good in underpants. So a couple of months ago, we decided to actually move the whole epic experience to the online world. And we came up with this concept, the online technology meetings. And today you have the pleasure and honor to do the number 7. So we are not even halfway to the first round, and we're already working on the third round. It's going to be at least 30. So not even 25%, Francesca, still a long way to go. And with the energies of the EPIC team, is something easy to do. So for those of you who don't know EPIC, EPIC is the least important organization today. Our job is to make sure that you shine. We have now the support of 550 of you telling us that we are doing a good job. So please keep the positive feedback going. We are not ashamed. We are not shy at all on receiving it. So I just would like to tell you and let you know as well that many of you are EPIC members. Those of you are EPIC members, I don't know why actually, but many of you are for the EPIC members. There's a set of meetings when the situation goes back to normal. The thing is over and we are travel, go back to travel 200 days. No question about that. Organize a good set of upcoming meetings. So this is the agenda for the meetings after Q4. But most important is that still you have the chance to access the market reports. And a couple of things. And why am I mentioning provided to you 1 month ago, the global blue laser diode market, in which it says, quick reminder for those of you who are already .com, the website for both the companies looking for talent, so we are experienced. And with this, we go to the important topic today, blue and UV, much better like that. Francesca.
Test the menu, makes sense. Especially when the menu is different and we will have super insights about submarine imaging. Then there is laser supplier, for example, which kind of laser can University of Glasgow is kind of lasers, and hopefully we can also integrators, so Nubura and OPI Photonics, so them to be integrated, these lasers. And then of course we have our service and equipment when UV and blue lasers are involved. Optic filters, so everything that is, and also from components PDF, so power supply is important, all of sector. So now I don't think
showing this experience to the YouTube universe. The people watching us in YouTube, and most important, if speakers, any of the participants at the meeting today, send me an email and I will introduce you. Questions in the YouTube channel, and please also give us something that EPIC is doing by bringing the industry together. And with this, the first speaker today, which is beautiful, beautiful Warsaw. We go to a photonic company in the world. Thank you very much. Yours. Stephen, clear now.
Okay, well, greetings from Warsaw. It's a nice day here. Unfortunately, everyone is locked down, so the whole city is quiet. So that's great. Anyway, so thank you for inviting me to give and I'll try and keep it pretty short.
So you can click the button share screen, and then we can accent all the way from Scotland, as you can notice.
I'll talk about blue and UV lasers. In TopGaN, we have epitaxial gallium indium nitride material system. Now, aluminum gallium indium nitride material system, that allows us to fabricate laser diodes from about 370 nanometers all the way into the visible and about 530 nanometers. And on the left-hand side, you can see the atomic diagram of roughly how you can tune the wavelength of the laser by putting indium into the mole fraction of the quantum well. But you've also got to put a lot of aluminium into the cladding region. So this means that when you're growing on gallium nitride substrates, the epitaxy is highly strained. So that's one thing to factor in, and that introduces the actual fundamental limitations on the wavelength you can achieve. But with TopGaN, we've got access to gallium nitride substrate, which was a big challenge to grow gallium nitride lasers. But you need a very high quality substrate to do to grow the epitaxy on. We have the choice of to grow on MOCVD or MBE, and the main focus of this talk is actually on single mode operation. So this slide here shows a cross-section, a schematic cross-section on the left-hand side of a laser. On the bottom we have the substrate. Then we have cladding regions of aluminium gallium nitride, N and P on top, going down into the active region, which consists of indium gallium nitride, and you control the indium mole fraction of the indium gallium nitride to achieve the wavelength you desire. And roughly speaking, you're wanting a few percent for UV, going down to about 20% for the green. We manufacture ridge waveguide lasers, shown schematically on the diagram on the left-hand side there. And on the right-hand side, you can actually see a real laser, and that top dark stripe is actually the actual ridge of the laser. So the light comes out of the slide. So in other words, the light is perpendicular to the plasma. So just to give you a quick idea of the characteristics of our lasers, this is a diagram of the LIVs on the top left-hand corner. So typically we see a threshold current of about 50 milliamps for our standard lasers, with about up to about 100 milliwatts of optical power, with a turn-on voltage of about 4 volts. On the top right-hand diagram, you can see the transverse single mode beam profile. That's the far field beam profile. And if you look at the output spectrum, you see a fairly typical multi-mode spectrum, as you would see from a Fabry-Perot laser. This particular laser emits at 420 nanometers. And we manufacture, obviously this is a laser chip, typically of about 500 microns in length, cavity length. So they are small, robust, cost-effective sources. We are interested in developing narrow line width devices, typically down to about megahertz in high power. And the focus of this presentation is on blue and UV for quantum technologies in particular. So to achieve the line narrowing, there's really two ways we can go. We can think about a gallium nitride laser diode in an extended cavity. And that's on the right-hand side, you can see some photographs and some diagrams of our extended cavity gallium nitride laser diode. We've also been working on putting the grating on chip. Now, we actually have fabricated and tested some sidewall epitaxy gratings, which is a little bit different from a conventional DFB laser, but we've been seeing some really nice results with that. So for example, if you look below threshold, there's a diagram of the spectral output versus drive current. And you can see once you increase the drive current, you can select a single mode. And that is a really interesting result for quantum technologies because you're wanting to achieve a very narrow line width. And it's also of interest for telecom applications as well. And just to give you a comparison about the line narrowing from the DFB grating, on the right-hand side you can see the spectral output from a Fabry-Perot laser. This is fabricated side by side beside the DFB laser on the right-hand side, on the left-hand side, sorry, in the red. So on the red trace has got the DFB grating. On the right with the black trace, there's no grating. And you can see with the DFB, we're actually seeing very narrow line widths, which we can achieve with our lasers. So that really concludes my talk, just to give you a quick glimpse of what we're doing in Poland. Okay, thanks.
Thank you very much, Stephen. Thank you for a great presentation. I went to visit you in Warsaw last summer when the whole situation was normal, and you told me about all the activities that you are doing together with all the different clusters, but mostly with the area around Scotland on quantum technologies. Today is your first ever EPIC meeting, so welcome. Okay. Family.
Thank you.
Every speaker always gets the same question, and I'm aware you were not warned. And the question is very simple. What can you do for them, and what can they do for you?
So, was the question again? Sorry, what
can you do for the rest of the supply chain, and what can they do for you?
That's two questions.
Yes, 2 in 1.
Okay, 2 in 1, right? Okay. Well, obviously, we're interested in getting our lasers out into the market. So that's one of our main goals. And that is, so it's obviously of interest is to get into that supply chain. And that either is in a packaging level or in a system level. So I'm interested in speaking to potential end users for blue lasers. Okay.
Are there any questions for Stephen? I think Richard has a question, but you're still muted. Let me unmute you. Richard from Nuburu.
Hi, yeah, I'm Richard Gleason from Nuburu. We're a blue laser manufacturer using blue diodes. I was interested there, Stephen. How do you change the wavelength? How easy is it to change the wavelength? I'm not talking about your single mode devices, but the multi-mode.
Yeah, like basically it comes down to the epitaxy structure.
Yeah.
So you grow the epitaxy structure and you're putting in layers of indium gallium nitride as quantum wells. And basically the quantum well gives you the wavelength of emission. Okay, and that's really the crux of getting the wavelength right. That sounds easy to say, but it's a huge challenge for the crystal growers.
Right.
Okay, so typically when you grow an epitaxy structure, you're talking about, say, a center wavelength plus or minus 2 nanometers tolerance.
Okay. Right, that's interesting. That's very interesting.
Indeed, I think I see the very clear room for collaboration. As Richard said, they actually to provide blue lasers by integrating laser diodes. But Stephen, I want to also help you with your supply chain, and I have a company all the way in Finland, Comtech Solutions, who make, I think, the best passivation process for 3.5s I have ever heard of. Joko, how are you doing today?
I'm good. How are you?
I want you to tell my friend Stephen how you can help them.
Yes, so what I was actually going to ask you that, do you issue in these blue laser similar issues that you have in side emitting red devices like COD damage at the side wall or side facet of the
sorry.
Yeah.
With gallium nitride, you can't do a one-to-one correspondence with gallium arsenide or indium phosphide. Yeah. And it's still quite an active area of research at the moment. Yes. And how could I describe this? There's a lot of activity, particularly in Japan, okay? And no one talks anything about it, really. So it's a bit of a kind of cloak and dagger kind of subject, but it's different from gallium arsenide and indium phosphide.
Yes. Yes.
And there's several different aspects to it. One is the actual wavelength, okay, is one thing. The other, which relates to the epitaxy. The second factor is the quality of the cleave, then the passivation, then the coating, then the environment you're actually testing in. So it's actually quite a complicated picture.
All right. So basically, what we do is we have a technology to passivate many 3.5 materials, including gallium nitrides, and we see this as a very good opportunity. Also, the gallium, we know we have mainly focused in some for gallium nitride the power electronic transistors, so passivating the aluminum gallium nitride gate dielectric interface. But we know that this could be our technology could be applicable also to the optoelectronics devices. Mm-hmm. And what we basically do, we create a crystalline oxide surface on 3.5 materials which have low level of defects and also which is important in many different applications.
Yeah,
I see this could be a very interesting.
You definitely should
also.
talk offline. I mean, actually, Yoko can reduce the amount of defects the top layer by 99%. So we are talking about something truly amazing. I get goosebumps. I introduced you already to many 3.5 laser manufacturers. They all get really excited. The future is very bright for Comtech. You just got a big award. So I know things are looking really bright in Finland. I have a question from Roy from PowerPhotonic. Roy, thank you for being here with us. How can we help you?
Yeah, I got a few questions actually. One is, what is the shortest wavelength that you can operate a laser at?
In the aluminium gallium indium nitride system.
That's right.
At the moment, that's a little bit of an open question. Now, you can manufacture a reasonable quality laser up to about 400 nanometers.
Yeah.
Okay. Going shorter than that, then things start to become difficult. And I would say we can get down to maybe about 370 nanometers before things start to become problematical.
Okay. And are there material systems you can work with that go to shorter wavelengths?
Not really.
No.
It's a bit of a, you're really falling off a cliff as far as the technology is concerned. It looks very similar to the so-called green gap in semiconductor physics. Where you're trying to tune from a phosphide laser from red into green, for example, it just kind of falls off a cliff. And at the moment, that's what it kind of looks like with the nitride system once you go shorter than 370.
And there are some material systems for deep UV LEDs. Will they ever turn into lasers, or will they only be LEDs?
Well, that's a bit of an open question, and difficult to give you a straight answer at the moment. Certainly, there's a lot of interest in LEDs, which are very short wavelengths. The LED and the gallium nitride laser, they're basically the two different technologies nowadays. Okay. They're completely separate. But the big issue is once you go down to shorter wavelengths, the aluminium mole fraction is going to go way up to get the wavelengths right. Okay. But in a laser system, you put in so many defects that you can't get it to laze. So there is an incompatibility as far as the two devices are concerned, and it's mainly due to strain in the material system.
Okay, thank you.
Thank you very much, Stephen, for a great presentation. There's a lot more opportunities I want to discuss with you. Later on, we're going to talk to the University of Glasgow about the single frequency blue lasers they make there. Quite outstanding. There's so many business opportunities, but we need to move on. And the next presentation goes to USHIO. Thank you very much for being with us today. It is going to be a great one. Ardan Fuessmann is going to tell us about their supply chain challenges and the potential opportunities for collaboration. Thank you very much. The floor and the attention of everyone here and the YouTube universe is yours.
Hi, everybody. Hi, Jose. Thank you for the introduction. Can you hear me? Yes.
Loud and clear.
Okay, perfect. So after a few hours preparation, I try to make my best to make the basics or the most important parts of our violet laser diodes in 6 minutes. My name is Ardan Fuessmann. I'm taking care about the solid state lighting business of USHIO in Europe. And many of you, of course, wait, how does
you click the share button?
It's not shared yet. I wanted to present to myself only.
Yes, the share button at the bottom, use the delicate touch that you're famous for. There you go. The floor is yours.
Okay, so again, thank you very much and welcome. And but I cannot switch the page one more. Now here we go. So many of the people in the photonics industry connect USHIO mostly with the history of the lamp business, where USHIO is working for 60 years already in different kind of lamp technologies, UV lamps, IR lamps, cinema lamps, whatever. And in 2014, USHIO decided to invest in the future technology in lighting, in the solid state lighting. They purchased different kind of companies. One company was the laser diode department and R&D center, was founded 40 years ago from Hitachi, and made some business with brands of Opnext and Oclaro. Additionally, Epitex, LED manufacturer from Kyoto, was purchased. These two companies were merged into USHIO Opto Semiconductor. And 1st April 2020, now 3 weeks ago, USHIO Opto Semiconductor was integrated completely into USHIO Inc. So the advantage of to have everything in USHIO is now that we have everything in-house, from R&D, epitaxy, packaging, everything. So we are working with 6,000 people around the world, of course, a lot of lamp business, but also we integrated different kind of knowledge and production facilities and machinery together, that we have the whole process in our hand. This enables us, besides all the standards laser diodes, which we have, for example, we have also a lot of customer specific solutions and working a lot with customer on specific ideas, which they will not get on the market. To focus on the laser diodes, we have a standard portfolio in the moment from 400 nanometers to 850 nanometers. The key, or the main focus, of course, from history also 40 years ago, is of course red laser diodes from 633 up to 700 nanometers, where we have from 5 milliwatts up to 3.5 watts, all different kind of power levels and different kind of pin outs. Typically, we deliver all laser diode chips in TOCANs. Of course, sometimes if some special projects coming up, we always have to check individually if we can do something special for the customers. So a single mode normally up to 200 milliwatt in the red, and above then the multi-mode up to 3.5 watt. But some years ago, of course, we add another focus. After many customers came to us and asked, we need alternative for UV laser diodes. So at this time, yeah, more or less one player was on the market with laser diodes, with UV laser diodes. So the USHIO invested a lot of money in the last years to make a lot of R&D capacity free for bringing some different kind of products in the UV laser diode market. Let's going more in focus. So in the moment, so we have different kind of multi-mode laser diodes for 404 or 405 nanometers. We're starting with 150 milliwatts, going to over 500 milliwatt, 600 milliwatt, and now it's already for some years mass production status 1 watt laser diodes for 5 nanometers with photodiode or without photodiode. Additionally, we have also a single mode laser diode with up to 300 milliwatt, which was introduced about 2-3 years ago. And for the future, of course, we are working already on the next products, the 375 nanometer laser diode, for example. We shipped out the last months the first samples to our customers. First feedback we got was already promising, and we're collecting the next months the last feedback and expecting mass production status in end of this year. So although there I'm really looking forward. We try, of course, to increase for the multi-mode products the power as best as possible. So we will get most probably in the summertime or after the summer, depending on the time now in the moment, with also home office in Japan, to get this finished with 3.5 pulsed version of 4 or 5 nanometers, and for 600 milliwatt efficiency improved version of our 4 or 5 nanometer laser diode. We got try to improve this all the time, and I'm happy that I'm 3 seconds before 6 minutes finished. So thank you for your short attention. In case you need any information about this product, you have any ideas or questions, please feel free to contact me always with my email. It's written here, ardan.fuessmann@ushio.de. I'm sure it's also, I think my LinkedIn link is on the page from EPIC for the presentation today, or also ushio.eu. It's always a possibility to get in touch with me that we can talk about more in detail about the different kind of possibilities. Thank you.
Thank you very much, Ardan. But then let's say we can talk in a bit more in detail already now. If you maybe tell us the question that maybe is still a bit open. So what can this audience do for you? Because you showed pretty well what you can do in UV, and especially for laser diodes, it was a good point. But what can the people here can help you with?
So I would start with the other way around, like Jose asking always a two question, what can we do for the market? Yeah.
I was sparing you from this, but if you want to say it, you're very welcome.
So at least what we can do for the market to offer alternatives. So we know the UV laser diode market is a difficult market where a big player is ruling the market and gives customers sometimes a little bit unflexibility. There we want to just offer alternative, and maybe also for smaller companies, for mid-sized companies, to be also kind of more flexible with selections or pinnings or whatever, that we can closer to the customer needs, away from the standard product. But of course also for standard products that there's a different chance. What my hope is to get from the market is a chance that the people thinking about for the next project or for current project to think, makes it sense, or maybe let's try USHIO laser diodes if it's worse, or it's the specific specification fits for my project and give me maybe here or there any advantage. And this is something I say to be open. And because I'm sure many customers or many potential customers, let's say like this, have never heard about USHIO and that they have UV laser diodes.
Very good. So now that you heard it, sound, there's USHIO also giving alternatives. Very good. And then what can the audience do for you? This is still the open question. Do you see someone here you want to maybe already collaborate with, or what is your feeling?
My only thing, what I have realized in the beginning when I checked the different companies here I have seen with TopGaN, for example, it's interesting because often we get many requests 410, 420 nanometers where we have no alternatives, or at least we cannot do it, that we try at least to talk to each other that maybe we can put them in the race for some projects where we have no possibility to avoid to support some other big players.
That's also avoiding that people go somewhere else. So, but Richard has a question for you. So Richard, you can tell it yourself if you want. You wrote it in the chat, but please.
Yeah, thank you, Ardan. So I was interested in what are the main applications for the UV and the violet? Is it bioinstrumentation?
So one key focus is the photolithography process. So maybe, as you know, or maybe some people know, we have also inside USHIO, we have the company Atec as a daughter company, which making photolithographic machinery. And of course, this was most probably also one of the driver to make our own laser diodes for our own machinery.
Right.
And left and right, then some different kind of projects popping up. In the moment, some 3D printing applications coming and using our laser diodes in the pre-stage often, and for some developments. And it's going completely in so many different kind of directions. So we have learned also for the 375 what kind of different kind of fields the people are working with. Yeah, from microplastic analytic in water up to what any other medical or biomedical application. So it's a really wide field. So I think the only main field or the main application which is coming more often is the lithographic process, photolithographic process.
Yeah. That's exposure of photopolymers.
Yeah.
Yeah.
And otherwise we have some different kind of customers really. This is going from sensor to medical.
Okay. Thank you.
You're welcome.
So now maybe we go back to a question again from for TopGaN. So Igor monochrome, maybe you have the floor now. We muted you earlier, too early to proceed, so you can ask again.
Yeah, thanks for that opportunity. I thought I already have been too late by asking this. Yes, my question was, I mean, monochrome is focusing on mounting laser diode bars. So my question would be, do you plan to build or to grow laser bars with several round of emitters? Is this planned, or is this something that you do not would focus on?
Yeah, like it's something we have been interested in doing. In fact, we actually won a Eurostars project several years back to actually develop laser bar technology. At the moment, it's actually gone a little bit quiet. And there's a couple of reasons for that. Is that our competitors have overtaken us, basically, because there's a big drive for processing copper in particular. So there's a lot of big players doing that. Now, potentially, if there was a niche market for high power laser bars that didn't compete head to head with the major players, that is something we could be interested in talking about.
Okay, thanks.
So, very good. Are there other questions from the people here? Because if it's not the case, maybe we can ask a bit to introduce themselves, the non-speaking audience here. For example, Seiya from Hoya. You are one of our best customers in the audience. So maybe you can tell us today why you're here. We're really happy to have you. And what is a bit that you can offer to this wild audience here?
Yeah, actually, we are the current filter supplier, and we provide various wavelength filters to cut or to through the laser. And we have also provide some encoding methods for the filters and to use the laser effective. And so, yeah, actually, I try to find a potential customer to sell our products, and yeah, let's say like we're an integrator for the lasers. So we can propose various options, and we can propose also some samples for that. So yeah, it's just to find the market opportunity.
Very good. So now everybody knows what can you get from Hoya and from Seiya in particular. So this is also why we are here. So now I made a bit of suspense because now we are really all looking forward to Luigi's talk. So we have this submarine imaging topic that is really exciting. So please, Luigi, yeah, this we see it very well. If you go in.
Yes, okay.
Yeah, perfect. Luigi, the floor is yours.
Thank you. So good morning, everybody from Rome. First of all, thank you to EPIC for this kind invitation to this very, very nice meeting. So just a few words about my institute, ENEA from Italy. We are a research center with more than 3,000 employees. We have a lot of activities. Our core business is nuclear energy, nuclear reactors, but we develop also technologies for the environment, from the industry, and so on. Okay, so today I'm going to give you an overview of what is our activities on the use of blue laser diodes for underwater 3D imaging, with a focus on the acquisition of 3D models. So it is very known to everyone how much it's challenging to acquire an image in underwater, and especially in subsea environment. This because water is not a cooperative medium for light transmission, at a difference of sound. We know that sonars works very well in a subsea environment, but it's very important. It's very important to acquire images in the subsea environment because a lot of industry applications are moving toward the subsea environment. So far, the main methods to acquire images in the subsea has been the use of conventional photo cameras. And if from one side, this is a very simple technology, it's easy to use, from the other side, it comes with a lot of limitations. The images taken with the photo cameras suffer of low contrast, limited range, there is color alteration. So this has hampered the limited so far the inspection capabilities with these techniques in industrial application. Some improvements have been done in recent years with the development of algorithm for post-processing the images and thus having enhancement in terms of contrast and precise coloring. But we are still far from what are the end user needs. And when I'm speaking on end users, I'm talking about industry and operator infrastructure in the subsea. So during the recent year, there has been an interesting development in smart imaging in underwater, and this is accomplished by the users by using laser light. So this has been proven to be a very efficient method to improve the contrast of the images to extend the range. Operative range is very important when it comes to acquisition of 3D models or imaging in a subsea environment. There is also the possibility to acquire the dimensional information on the models and also real colors. So this has brought a wide interest from a lot of industries like the subsea operator of oil fields. We know that inspection of assets in subsea is very important. Also the security sector is interested in interest in this technology. For example, we are running a project for the detection of unexploded mines in the bottom of the sea. The nuclear industry, we know that most of the reactors operate in water. Water is a cooling system for the nuclear industry, and sometimes inspection have to carry it out in the contaminated environment of water. I will show you later on some example. Cultural heritage is another field of interest for this application. And last but not least, the use of the technology during the naval disaster relief. Okay, so in this game, blue laser diodes play a very important role for several reasons. Because first of all, pure water has a minimum of absorption around 450 nanometers, so makes this laser source is very suitable for extended range application. Today, blue laser diodes are available off the shelf. They are compact with low power consumption, thus allowing for miniaturization of the final device. There is an increasing trend in producing a system with optical power output, with more and more optical power output. There is a possibility of efficient coupling in single mode fibers. This is another very important point for the final application, and also the possibility for amplitude modulation in digital and analytic mode up to radio frequency range. So this is very important, and it makes blue laser diodes ideal sources for triangulation and amplitude modulation system for 3D underwater imaging. So this is a system, a device that we have realized in our laboratory in ENEA. It is a scanning 3D laser imaging system that is qualified for operation in the subsea environment up to 1,000 meters of depth. It is based on 450 nanometer laser diodes with analogic and digital modulation up to 350 megahertz. Is a single mode laser from the spatial point of view, and is coupled with a single mode fiber with a monolithic pigtailed solution, which gives the system, the whole laser system, very high stability. And this is very important to understand the very harsh operational condition in the subsea. Keep in mind that this system is designed for operation on board ROV, industrial class ROV, and ROV can experience up to 4G of acceleration. So the system should be very, very stable from all the point of view. So the system is tethered with the surface vessel by a cable with optical fibers. So this is an example of the 3D model acquired with our system is a spool piece and was located 10 meters from the sensors, and the water was the typical coastal seawater that you can find in typical operative conditions. So the model reproduced the dimensions, of the real object with an accuracy of 4%. So back to the application for nuclear industry. Here we have an image of the nuclear reactor that we operate in our center of ENEA on left, and on right we have a picture of a system that we have developed for use in the reactor vessel. So keep in mind that the water in the reactor vessel is contaminated water with gamma ray and neutrons. So all the technology that is installed inside these devices must be radiation resistant. So it's been a very big technological challenge to develop and to demonstrate the use of the system in the nuclear reactor. Here we have a typical 3D model acquired with the system. In the bottom of the image on the left, you can see the grid of the fuel rods, and the distance from the laser head to the bottom of the reactor was 7 meters. So finally, I would like to show to you another application that is possible when a blue laser is coupled, is mixed with a red, a green laser to have a single output with an RGB laser beam. This allows the recording at the same time of the 3D shape of a sample, but also the real colors through the RGB method. And you can see the 3D model of a sea sponge that we have recorded in our lab, in the pool of our lab. So the details have a resolution of nearly 1 millimeter. So this is just an overview of the potentialities that the use of blue laser diodes can have in this emerging field. It is the subsea imaging, underwater imaging. So I think that's all for me from my side. I'm done, and I would like to thank you for the attention, and I leave the floor to the chair. Thank you.
Thank you very much, Luigi. That was impressive. When we heard about you and we heard about the work that you do with blue lasers, we got really excited. And our expectations are always very high, and you went on the top of them. That was really fantastic. Thank you for this. Having a user telling us what they can do with our lasers is priceless. In your presentation, you talk very highly about blue lasers. You talk about they are compact. You talk about they have low power consumption. They have the right wavelength. But this is Santa Claus Day. It's 25th of December. As for the Christmas list, you have all the blue laser manufacturers here in front of you. What can they offer you that you don't have?
So keep in mind that we are a research center, so we are open to collaboration by design. So in particular, we work in the scheme of a European project, a NATO project. We have a lot of projects funded by NATO, project for small and medium enterprise like Eurostars is a project from the European Commission. So we offer our full collaboration, our expertise to collaborate for new project and to make available to all the technology providers our experience, our test bed, our network collaboration with end user to test the solution in real operative conditions. So this is the best that we can do, being a research institute, obviously.
We're going to find you some good project partners here. Everybody's very excited. Are there any questions for Luigi?
Yes.
For me, the clear question here is that when you tell me about the 3D laser imaging thing, the beautiful, big thing, you tell me it's 30 kilograms. And I got a bit shocked. What is the heavy part of that? Why is it so heavy?
So you are talking about the
3D imaging system for subsea application.
Yes, it's heavy because it depends on the range. You can develop a smaller device, but you will limit the operative range at the field of view, because as you can see, there are 2 optical windows. And so you need optical windows it's a scanning system. The laser is a pencil, it's a ray, and you need to scan the system, to scan the laser along the optical windows. And you need an optical window for the launching stage and an optical window for the receiving stage. This is essential. So I can, yes, great. So it is necessary to separate the launching stage from the receiving one. This is why you have two optical windows. Because otherwise, if you are adopting a single optical window, so a monostatic scheme, you collect the light radiation best scattered by the water. Yeah. It's special filtering. So this is the need, the need to separate the two optical windows. And so in addition, if you would like to go in depth, you need to develop a system that is resistant to pressure. And so this is why you need a so heavy envelope, of heavy container for the system. Keep in mind that we have mounted the system on industrial ROV. Industrial ROV, that the one that are used in subsea oil and gas industry. So this payload for this kind of ROV is nothing. They can bring more and more heavier stuff. It depends on the application you want to. We can reduce the dimension, but it is another range of application. If you are targeting industrial application, you have to develop a very compact and a RAG system.
In terms of power, when you were talking about the different powers that you're using, normally I was surprised also that it's in the low range of what I was expecting. We're talking about tens of milliwatts for 3D imaging solutions. Are you looking for higher power? Are you interested in collaborating with these people on that?
So, okay, it depends on the sea, on the water condition, the turbidity. For example, if you are targeting application in the nuclear industry, keep in mind that the water in a reactor vessel is very clean. So this means that the laser light propagates very easily. So there is not the necessity, the requirement for high power. Few milliwatt can be enough. If you are targeting application in the subsea when there is a high turbidity, you need tens and tens of milliwatt. So it depends on the application. In clean water, few milliwatt are enough, and this is for the nuclear industry. Subsea application with high turbidity demands more and more power.
Let me introduce you to one of your future partners in a European project. Anthony Kelly is the leader of Blue Lasers at the University of Glasgow. I went there. It's a fantastic place. I cannot wait to go again in September for the EPIC World Technology Meeting on Quantum Technologies. But Anthony has actually worked heavily on making single frequency blue laser diodes, right, Anthony?
Yes, thank you for inviting me, and also thank you for giving me an opportunity to wear a shirt for the first time in a month. So yes, I work with Steve at TopGaN and a few other laser manufacturers to make single frequency blue lasers, and obviously I'm interested in the applications associated with them. So your talk was very interesting, Luigi, very interesting. I don't know about you, but I find dealing with the oil industry quite difficult. I was having this conversation at the weekend. They are either making loads of money so they don't want to speak to you, or they are making no money so they're firing everyone. So you have to kind of find the transition between these 2 points, and it is very how should we say, very changeable due to the oil price and so on. I do believe personally that blue lasers will have a role to play. I was wondering how you managed to interact with industry and get the undivided attention of the oil industry.
So these questions comes from Scotland, and so it's normal. So we have worked a lot with Aberdeen. We have worked a lot with Aberdeen companies during the golden age of the oil extraction in the North Sea. Now, I'm talking about 5, 6 years, 7 years ago. Now the situation is declining, but there is a shift in the application. So it seems that the wind farm will be installed in the sea, and this open all a new market segment, for example, for the inspection of mooring chains. So it's likely that this installation will not be so sophisticated like oil and gas rigs. They will be based on mooring chains that need inspection. So I do believe that we are in a phase of transition in this market segment, and we should have been able to catch the new opportunities that will arise for sure. And there are a lot of projects that are still in the development phase that very soon will turn into operational phase, and the technologies could have a revamp in this way. Okay. So I agree with you. It's a time of transition, and we have to give our eyes wide open and to catch new possibilities.
From the YouTube universe, we have Juha Kopinen from Oblatech. How are you doing, Juha? Good to see you. So he's wondering, do you need radiation-hard optical fibers, I guess, for your nuclear activities?
Yes, for sure. It's one of the most important part that should be hardened from the radiation point of view, should be radiation resistant. It is a very big issue, and obviously we are open to collaboration with all the partners that have an expertise in this sector. We have important European project in which we participate, and they are devoted to the further improvement of the system. So we are keen to collaborate with new partners, obviously.
I will introduce it to you offline, and let me also remind you once again that anyone who wants to be introduced to each other, we don't share the email addresses now, of course, but you send me an email and I will make sure I get introduced. This is valid for the people in the room as well as the people in YouTube. Thank you very much. Grazie mille, Luigi. We move ahead with the program. We go to Chris Erickson from the UK, from DSTL, Defense Science and Technology Laboratory, to talk to us about a different market segment, the defense sector. Thank you very much for being with us. Tell us how the supply chain can help DSTL.
Well, thanks, Luis. Thanks for inviting us to be part of this today. We're really excited. We represent a little bit different part of the market from the defense side here. You're probably wondering why my outrageous British accent matches your expectations. I'm actually an exchange officer from the US Air Force to DSTL. And I'll give you a little bit of an overview of my corner of the organization, and we can talk about then what we're kind of looking for in the blue laser market.
Fantastic.
So we are the Quantum Sensing Project, and inside that project, I actually represent the time and frequency. What we do in general is we look at developing technology, basic science, and we want to transition that into products and things that the military can use for defense purposes. And we do that specifically for quantum devices. So we take our guidance from these 3 documents that the UK has put out. We don't have to go through this now, but you're welcome to go read them on your own. And that will tell you something of the direction that we look at. We're specifically interested in position, navigation, and timing, and sensing applications, so magnetometry and gravity, time and frequency. And we really are growing fast and would like to become one of the world leaders in developing engineering for these quantum sensing systems. One of the limitations for these systems is they are confined to the laboratory. So you hear a lot about quantum in the news and the press lately, especially with quantum computing, but it's really not getting out of a laboratory and onto something like a ship or an airplane or out into the world. And we're trying to break that stalemate by helping to push and develop the technologies that can get these sensors off of stabilized tables, off of quiet laboratories, and into a noisy environment like a car or an airplane or out in the world. so we do have these sections of the group. There's time and frequency, systems engineering, sensor concept and development. We run several PhDs to try to leverage new technology, and we've established an in-house laboratory for doing this work as well. I should say that the system engineering block here is really important. This is where a lot of our focus is, finding out what are the parameters for how do you run stable laser systems in an environment with a lot of electromagnetic radiation, a lot of vibration and shock. How do you isolate those systems? How do you keep those from affecting the atoms, which are the basis for all of our devices? And it's not easy. It really takes quite a lot of work to isolate a quantum system so that it's useful. And then our success really looks like delivering these devices, right? So what do we do for real? We take basically vacuum chambers and put atoms inside the chambers, and then we access those atoms with laser beams, and we can configure that very simple sounding system in a number of different ways. You can that basic system provides quantum computers, it provides magnetometers, it provides atomic clocks, it provides gravity gradiometers and gravimeters, and that is the magic of an atom, is you can pick any element and use it probably to do these things. They are sensitive to all these different effects, but that is also, of course, the thing that kills it, right? It's so sensitive that you have to isolate everything else that you're not trying to measure at the same time. And so the blue laser diodes and laser sources come in because different atoms have different energy transitions. And we would like to access transitions in certain atoms for making these devices. So we're interested in strontium, which has transitions at 461, 421, 408. We're interested in calcium, which has transition at 423, and ytterbium.
Chris, can I interrupt you? Did you stop sharing the screen?
Yeah, I did.
It would be.
Do you want that back?
If it's back, if it's not the last slide.
Yeah, that is the last slide.
Okay. Then sorry.
Yeah.
You can go on.
I apologize. We didn't. I don't have a lot of slides for you. I wish I did.
It's not a problem. Absolutely.
Yeah. So no. I would have liked to have more for you, but on the short notice.
Chris, you did fantastic, but don't please continue. So you are interested in the 461 nanometer transition, in the 421, and what others? This is gold for us.
Well, it sounds like gold maybe, but I'll get to that point in a minute. Because also we're interested in ytterbium, specifically 369.5 nanometers, and then also. Well, there's a bunch. Mercury has a transition at 266, which is really far into the blue, of course. But our problem and the wall that we come up against is because we're doing basic research and proof of principle. We are looking to buy 10 units maximum, maybe, right? We are not a big customer for people unless we succeed, right? Because then if we succeed, we transition that technology. That gets picked up by a prime defense contractor, and then somebody's going to buy thousands and hundreds of thousands and maybe millions of units. But to get the work started, right, we just need small batches, and that does not typically attract a lot of attention, as you can imagine. So we do work. We've had a lot of talks with Tony Kelly, University of earlier, or is still on, I guess, and we are still trying to get traction on these sources. Another issue that we have and that we face is each wavelength has different line width requirements and different stability requirements, which means that they're all kind of one-off solutions for our purposes. We a blanket technology that can hit a bunch of wavelengths might actually not work for any more than one from our perspective. So of course, there's a lot of detail that we can go into on all of this.
Don't worry about the volumes, because as you very well said, you're enabling a market that will grow. I'm going to give you an example. Like 3 years ago, I was working on free space communication, and everybody was saying, no, but this is for the space market, and this is going to be very low volume, I'm not interested. We had a presentation last week with Airbus already demanding millions of units. So this is an enabler, an entry point to a large market. You talk to us about 4 wavelengths, 461, 421, 369.5, 266. Do you have some demands in terms of power?
There are, yeah, so it depends, right? So 461 is, you know, a transition that requires a lot of power for strontium. People typically want on the neighborhood of 100 milliwatts. And it doesn't have to be particularly narrow, that transition, right? For ytterbium at 360.5, we actually don't really need very much power at all. You know, barely a flicker, really, and about a megahertz of line width. They all do have to be relatively narrow compared to most industry.
From Italy, from beautiful Torino.
Hi, Jose. I'm good.
You're doing a fantastic job in the R&D project. Can you tell him in a few words? You're going to give a presentation later, but can you tell in a few words how you could work together?
Here in the audience, so we have already some cooperation ongoing, some of our contacts. So I think that in Europe we have several. So basically, yeah, and it's a very interesting topic for our potential interest also within the PIC.
Chris, with current technology for the military that DSTL can do, can we position DSTL as an R&D center? One is like monochrome, adapting their lasers to a particular. I think we have you muted again. Let me unmute you. Yes, the company in EPIC has a role, and I want the role of DSTL to be the entry point technology to enter the defense world. Is DSTL on that particular goal to adapt different lasers to the military?
Yeah, in a sense, it could. You know, in general, things that line up with the interests that we have and the projects that we're working on, that definitely could be, for sure. Yeah, because we are not. We're government, right? And so to how we interact with industry players.
Any questions for Chris? Any questions for the quantum-oriented groups like Stephen or Anthony? I think you already know them very well, and I think there is also many people who want to ask. Thank you very much for a great presentation, and we'll continue with the program. Andrea, and we want to hear how OPI Photonics can help the rest floor, and the attention of everyone is yours.
Okay, so a few words about high-power blue laser diodes in OPI Photonics. Our company is basically divided into branches: high-power beam delivery system, mostly for multi-kilowatt fiber laser. I'm talking about mostly components, so collimator, couplers, switches, and optical system in general. And then we have a division about high-power diode modules. We started in the infrared business, and now in the last 2-3 years, we have moved our attention to the visible lasers, mostly blue, from 405 to 450 typically. And then we have also a third division that is about special products and custom solution. So the core of this meeting, this is an overview of our blue laser modules family. When I talk about modules, it means an optical components without the surrounding electronics. And we have basically 3 platforms. We start from a 15 watt in a 50 micron fiber. And we have a 30 watt in a 100 micron fiber, and then we go up to 100 watt in 200 micron fiber. So basically, we started mostly putting the attention to the brightness concern and to the low power hand applications. So mostly up to 30 watt, we're talking about micro machining, 3D printing, but very low power and high brightness application in general. And then now, more recently, we have moved to higher power with the 100 watt module. So the core of our technology is basically that we rely on TopGaN chips. So that's a strong choice for us, because it's mostly due to the fact that in terms of reliability, I think that's probably the best solution also in terms of supply chain. So we have several suppliers qualified suppliers, so we have no risk in terms of supply chain at the moment. And moreover, our architecture is quite flexible, so we can, let's say, use different wavelengths. So now we are focused, we started with the 450 nanometer, which is the most interesting application, most interesting wavelength for us, but then we have a lot of requests also for the 4 or 5 nanometers, so more to the violet. But that we can also integrate green and red diode, basically with the same architecture. Our combining architecture is based on several patented technology where we can achieve high brightness and basically quite complex solutions. So that's the core of our approaches, and based on the same platform, we can basically play with different chips, with different also supplier, and we design also our modules so that they are really compatible by design with different suppliers. So that's somehow the core of our products. In more details, so we have the single module without the electronics, but we have also turnkey solutions, so a complete system which is mostly conceived for the higher power, so let's say the 100 watt system, but we can apply also the same system concept, so a turnkey solution also for the lower power. It depends on the market, so we have customers that are more interested in a very small and compact OEM module that they can integrate easily and also keep lower costs. So in that case, we just provide, especially for the 15 watt and the 30 watt module, just the optical element, I would say. But then for the higher power, the interesting for a turnkey solution, of course, is growing. Then we have also used our experience in the beam delivery system, comes from the fiber laser, basically multi-kilowatt laser sources, but we're using the same experience also to provide components for the blue, let's say, optical chains, so collimators, process head. So because also since the market is quite new, there aren't a lot of components ready for that. So again, here targeting also high power, but also high ENEA, because the special characteristic of our devices for the beam delivery is that we can handle very high ENEA also, so that's typical for laser diode. So basically, we have a product line also that is support to the blue laser. So starting from our few tens of watt up to even multi-kilowatt, our units stop now at 100 watt, but we know that there is market also for the multi-kilowatt blue laser solution, and there we can provide components for this. So basically, that's a very, very quick overview of our product and our capability in the blue. Thank you.
Thanks a lot, Andrea, for your talk. So now maybe we stop sharing. There you go. So thank you very much. I see you have already something a bit different to offer, maybe for this audience that is needing only a few tens of milliwatts. So you're already addressing more a high power application, like you mentioned, like 3D printing. But what can maybe this audience here now do for you? Do you have, did you already hear some contributions so far? And also from the people that maybe didn't speak yet, do you have maybe, for example, some issue with packaging? You said you are really doing packaging also maybe for harsh environment. Is something that you can propose to this audience, or what comes to your mind?
Yes, for sure. I mean, as I mentioned, some of the speakers, I know them, we were in touch, so of course it's interesting to see them again. But yes, in general, our capability and our specialty is really the designing of architecture for the packing of this solution. So we typically target higher power, so the minimum is a few tens of watt. But in general, especially working with TopGaN, of course, the architecture is quite flexible and can allow also lower power. As I mentioned, we try to have a kind of a platform where we can play with different chip, with different wavelengths, different dimension. Just changing a little bit the layout, we can target different applications. So yes, it's quite flexible from this point of view, our architecture.
That's very good. And also, we have Richard. Yeah, Richard, there you go. You can ask the question.
Hi, Andrea, it's Richard from Nauru. So we compete on one level, but we stop at the end of the laser. So I'm very interested in your beam delivery components you showed there. So maybe we can get in touch afterwards.
Absolutely, no problem. Also because I think that in general you are targeting mostly high power end of the market, and we try not to be there. So even in terms of competing, I don't see a very strong competition. But in any case, absolutely, I would be very happy to have a discussion about all of this. We started with the infrared experience, I would say, but now we're moving also because of course we have the need of having some delivery system. So I would be very happy to have this discussion with you.
Yep, that'd be great. Thanks.
That sounds really good. So we have Luigi. Luigi, there you go. You can also ask a question.
Yes, so thank you for the very interesting presentation. So what about the possibility of modulating the intensity of the laser? This was analogic or digital. So what's the possibility?
Yeah, that's possible for sure. In our typical application, that's not needed. We have some very specific one that requires this modulation. So yes, I think we can for sure discuss about that. So it's basically driven by the specs of the chips somehow. So we can assemble many different types of chip and we can modulate. We do that. So especially when you have a low duty cycle application, we can also reach important peak power and maybe also some shorter wavelengths. So that's something that we already do. So we can talk about that. I know that your application is mostly lower power, but if you want to shine more your objects, I mean, we will be welcome.
So
okay, so yes, thank you.
Very good.
We can reach each other, yeah.
That's very good. So 3 at once. Then what about the power supply? Rene, don't you want to jump in this pool of collaboration?
Yeah, I'm now unmuted, I think. Okay, yeah, I will start my presentation. Thank you first for this meeting.
Rene, can I interrupt you just a second? I was just asking you if you can support Andrea with power supply. Of course, you can also start your presentation.
Yes, actually, we start even at a bit higher power. For us, is 1,000 watt really the minimum. But since the efficiency of a blue laser is not that high still, probably we can. But still, the power is a bit on the low side for us.
Okay.
But maybe we can talk afterwards and exchange some information. That would be good, I guess.
So do we have other questions here in the room? Okay, I see you're pretty quiet. So before we go to Rene, actually, let's stick to our agenda. So I apologize, Rene. I know you want to speak.
No.
But let's maybe stick to the agenda because we have still Roy from PowerPhotonic, and it's now his turn. So let's maybe go there and then we come back to Rene. What about that?
Okay.
So thank you, Roy. If you want to share already your slide, yeah, you're muted. Great.
Okay. I'm trying to share. It doesn't. Hang on a second.
Doesn't work. Now it's coming. It's coming.
Great. Thank you very much, Francesca.
Yes, very good.
So
the floor is yours.
Okay. So I'm Roy McBride, the CEO of PowerPhotonic, and we make high performance micro optics in fused silica. We're based in the UK, and we've been shipping freeform micro optics for about 15 years. We have our own fabrication process that we developed ourselves using our own equipment. One of the key aspects of this process is that it lets you take a design through prototyping to volume in one manufacturing process, so you don't have to requalify when you move from prototyping to volume. And we've invested a lot in automated production. The factory runs 24/7. That's been a really big benefit in the past couple of months. So we keep manufacturing 24/7, where most of our staff are sitting at home, as I am just now, with a small team in clean room suits, keeping things running. It's a direct write process that we use, and that lets us make a very wide range of optical features, from lenses and A-spheres, things like axicons, through to lens arrays of optics that are all different, such as arrays of axicons, arrays of vortex generators that you see here, are surfaces that look completely random, but have actually got quite well-controlled statistical properties. So the key point is this direct write process gives you a lot of design freedom, and that allows you to realize optical functions that you can't make with other processes. A key aspect of the process as far as UV and blue beams is concerned is the fact that it works very well with high power. It generates a very smooth surface with low scatter and low loss. And because all our parts are made in fused silica, they can operate down, when we choose the right grade of silica, to below 200 nanometers. So we can cover quite an extreme range of wavelengths. Most of the stuff we make is made for the near IR, so we're used to making optics for multi-kilowatt CW beams and multi-joule pulse beams, but they also perform very well down to high powers in the blue and UV as well. And some examples of the kind of things we make optics for both slow and fast axis collimation of high power diode lasers, and also for faceplates for optimizing the collimation of diode lasers. And we also make optics for laser beam shaping over a very wide range of laser types, as said, from high power CW through ultra short pulse, from the UV through to near infrared. And we make beam shapers for single mode lasers through to multi-mode lasers and very highly multi-mode lasers, such as high power diode lasers. We're interested in new applications in the blue and UV, particularly ones that need beam shaping or collimation at very high powers, things like copper welding, 3D printing, laser projection displays, and white light sources, laser pump sources, and also UV sterilization, which I believe so far is really just in the LED domain, but we're interested to know if that's going to move into the UV domain as well. And also very interested to know about any other emerging applications. So yeah, the point of being on the EPIC meeting is really to find out about new opportunities and new solutions. So what we're really interested in are new applications for blue lasers, for UV lasers, and LEDs as well, particularly where you need high performance management of the beam. We're interested in anyone with optical design and fabrication challenges in the blue and in the UV, because we don't just do build to print, we also do optical design as well, particularly where high efficiency is needed or unusual beam shaping is needed. And also we find we're in a whole new regime of reliability and lifetime in the blue, and as we move through to the UV as well, there's certainly less rel and less lifetime data for materials and for coatings as you move to shorter wavelengths. So we're interested in anyone with a good offering or good experience in high power CW in the blue and UV, and high fluence, especially with ultra short pulses into the blue and UV as well. So yeah, if you've got ideas in these areas, if you've got problems in these areas, if you've got solutions for us in these areas, I'm interested in talking now or in a follow-up discussion later. Thank you.
Thank you very much, Roy, and thank you for being one of the key companies having EPIC and bringing freeform optics to the beam shaping world. And that's really interesting to see how you are looking today at these more sexy wavelengths than the ones that we are used to talking, and you use all silica to cover actually almost any wavelength. If you could summarize quickly what you could do for others, but also what kind of links, what kind of operations you would like to do, what kind of business you would like to do after this meeting.
So I think we're particularly interested in first of all, very high power applications because their optics can handle high power CW, high power fluence. So things like collimation of diode arrays in blue, for example, and also in beam shaping for applications like additive manufacture and laser welding in blue as well.
I have somebody from in the room that didn't speak yet, and I don't like that. I want everybody to be speaking, and I have Guillaume from Unity. Unity is one of these success stories that we have in Europe. Guillaume, how are you doing today?
Well, good. I joined the meeting without expectations, but and I've been quite impressed by the diversity of topics. I'm also here. I have one expectation, though. I mean, I'm a user of blue and in the future probably UV lasers. The reason is I work in Grenoble in France, a strong cluster on microelectronics, and Unity is manufacturing, inspection, and metrology.
I think we are having some problems with stability of the connection. Just for those who couldn't hear, Unity is the key company having EPIC in metrology for the semiconductor industry. And it's been one of the success stories that we have built in the EPIC community. So we are super fond of them. Guillaume, are you back? Yes, now I can see you moving. Yes. So yes, that's better.
I'm sorry if my network is not really good. So I don't have fiber yet. So, yes, as I was saying, we are using relatively high power. That's very relative, really depends on how you look at it, but usually single mode lasers. To give you an idea, we're about, in the machines I'm dealing with now, we're using like 450 nanometers, but it's gonna go down to the UV. We need fiber connection. We deliver the beam to the wafers we are inspecting through fibers. And sometimes we have requirements on coherence. I could give you more details on that. Power range approaching 1 watt. And so I'm looking for what is existing now. I didn't find that many companies that were fulfilling our requirements. This is one of the idea here. I want to broaden my view on the market.
One of the key companies that can actually go with you on that is in the room, and it's Richard from Nuburu. It's one of these interesting companies for you in terms of power stability. Is one of the ones that I'm pretty sure you need to talk offline, right. Especially with the power range that you are targeting and your requirements for coherence. Richard, did you know already each other? Did you know Guillaume from Unity? Let me have you muted again. Sorry, my fault. Richard.
Yeah, no, I don't personally, but I don't know if you're in touch with our engineering labs in Denver, Colorado.
Not yet, not yet.
Okay, so let's touch base afterwards and talk about that.
All right.
Indeed. I would like to talk now about a topic that is very, very interesting for me and we didn't touch yet. And this is mostly for the laser diode manufacturers who are looking for packaging. For example, Stephen from TopGaN. Stephen, how are you addressing the packaging challenge at this moment? Are you doing everything manual? Do you use some companies to outsource the packaging? Sorry, have you muted? Yes, now.
Yeah, we have packaging partners.
One of the key challenges, what is the challenge that you have when it comes to packaging a blue laser?
Well, as I mentioned before, there's not a one-to-one correspondence between gallium nitride lasers and, for example, gallium arsenide or indium phosphide lasers. In gallium arsenide and indium phosphide, packaging has mainly been solved. But in gallium nitride, there's still a lot of unsolved problems or to be determined. And that's something we're actively working on with our packaging partners.
We have, of course, Mark from Alter Technology here in the YouTube channel. Hello, Mark. How are you doing? And we also have companies like Erickson Tech, Ben Griff also talking. They are very interested in having and understanding really the challenges of the packaging of these these laser diodes, and I already know you work with one of the companies I mentioned, and I think there is a lot more to discuss on that particular topic. And when it comes to add the optics, Roy, we have been discussing in many different fields, many different topics about the need for beam shaping. In this particular wavelength range, what has been, in your opinion, the challenges that you discussed so far with some of the companies for beam shaping?
So far, part of it's been high power handling. That's been one of the challenges. And that's one where actually getting the right vendors has been important. Getting vendors that can handle very high power, coatings that can handle very high power in blue, for example. Been quite important for us.
Richard, if you could challenge my friend Roy with a beam profile with some shape, this guy Roy can do almost any shape that you can think of. I see cool things.
Yeah.
So is there any challenge you have for him?
Sorry, were you talking to me, Richard?
Yeah.
It depends whether you want to talk in M squared or BPP, but we have BPPs in the order, which is the higher power unit of measurement, beam quality, in the order of 7 to 11, something like that. And then, you know, that's what's coming out at the end of the laser system. And then it's up to our customers how they want to shape that. So we get a whole range of questions and requests for how they handle the beam after that. The holy grail for us really is being able to get good enough beam quality to do scanning at high powers. So, but at the moment we're at a BPP of around 6 to 7, and our customers want to shape that in many different ways.
Okay. Are there any further questions? I think I would like to ask another end user. I would like to ask Luigi, because Luigi also is from the user side. Maybe you have some challenges on the beam shaping that you could ask Roy and the rest of the 500 companies.
Yes, okay. Beam shaping is an issue for our final system. Is mainly in amplitude modulator laser system. Is a very important feature. So we are ready to collaborate, to take new opportunities, new ideas, and to test in our system. So I agree with this approach, absolutely.
Let me go to the different sector, Chris. When it comes to beam shaping of any of the wavelengths that you have been targeting, is there any challenges, any particular unmet list, something that you ask every Christmas and you don't get afterwards?
Well, we're always shooting for as beautiful a Gaussian beam as you can get, right? Depending on the laser technology, they all come out of the chip a little differently, but the best for us is a really nice wavefront.
You have a lot of opportunities here, Roy. Eh?
Yeah, that's where we started, is taking collimated high power diode lasers and making that wavefront perfectly flat. So you got the brightest possible beam.
It works both ways, Roy. So you take, what kind of coatings, what kind of particular collaboration could you do with a company like Joya, for example?
Joya, I guess, Joya, you do fused silica?
Something in between people who are doing kilohertz or megahertz line widths and people who are doing super large.
Okay, so we if it comes to small or narrow line width laser diodes, in general they are using DFB laser diodes or with an external cavity. Unfortunately, external cavities is something that we still have to develop. We have some ideas to narrow the line widths based on VBGs, for instance, or other gratings. But currently, we do not have something that is ready to market.
Okay, just to encourage you, I would say that we are working in the best ever condition. Our mission go into clean rooms, so we're not doing undersea or it has to be very reliable, but the environment is very controlled, so that helps.
Okay, I mean we can exchange our email addresses to stay in contact. I will get in touch within the next few days with our R&D manager to fetch for the newest info about that research project.
You definitely need to talk. And Ardan, they are looking for narrow line width, a few hundreds of milliwatts. That's definitely something that you can provide from USHIO as well, right?
Sorry, please repeat it. I just to search myself on the screen.
Yes, I was just linking the two of you. There definitely is also a potential business opportunity for the semicon market. They are looking for narrow line width and in certain volumes, market-ready solutions for the blue area. So definitely something for you to discuss, but I will introduce you later on offline. I think right now with this round, we managed to identify lots of business opportunities, which is the reason for this meeting. So you're making me extremely happy. And now we move to the last presentation of the day. We go to the Netherlands, a beautiful, beautiful country where I actually live. And we go to the Netherlands to talk to Rene Dingshoff about a particular challenge when it comes to the power supplies. Let's see how PBF can help. Also in this industry, we are very happy to have PBF as a member of EPIC. We deal a lot in the high power sector with them. The need of having very stable power supplies with low ripple has been great as a great addition to the EPIC network. Let's see how we can help also in this range. Rene, the floor and the attention of everyone is yours. Thank you all.
Thank you. I will share my screen. I think you can see it now.
Very well and very clear. The floor is yours.
Yeah, now it's working. Yeah, we are PBF from the Netherlands, like introduced. Thank you very much that we have this opportunity. Came on short notice, so I had to prepare everything today. But so I made a small presentation first, a bit about the company. We are a former Philips company, now part of the SFC Energy Group. We have production and R&D location in the Netherlands and Romania. And we are specialized in power supplies for lasers. So we are not experts on laser itself, but as you know, every laser needs a power supply, a current driver, whatever, to be able to work. What do? We have off-the-shelf products, so ready to use for different kinds of applications. We have what we call modified standards. So if we have a power supply that is close to your needs, we can modify it to your standards so that it will meet exactly your standards. And if you have bigger projects and you want to have something special, we can do full custom. On group level, we have about 250 employees. So that's basically PBF. What can we do? What is our technology base? We are mostly in high power. For us, we start at 1 kilowatt of electrical power, depending on the efficiency of the laser. With 1 kilowatt, with the blue laser, you can maybe make 200, 300 watts. With other lasers, you can go up to 400 or 500 watts. And basically, we have no limit in output power. I say 100 kilowatt, but if you need more, then we can deliver more. What do we make? We make voltage sources and current drivers. And with fast current drivers. And for somebody, some of you, fast means megahertz. For us, fast is rise and fall times about 5 microseconds, but on kilowatt level. We can make compact designs, for instance, in a 3HE or U 19-inch rack. We can do 21 kilowatts. So with the ever need of making your system smaller and with more power, we can supply you with really compact designs for that. If you go to the high power, for instance, metal cutting, 3D printing, welding, you need probably a combination of DC and pulsed. So our power supplies are able to deliver both actually in one system. We have power supplies for fiber laser or diode bars, but mostly in the higher power. So you have to talk about cutting systems of 2 to 20 kilowatts. Or these kinds of ranges, there we are specialized in. What makes our power supplies unique? It's probably the integrated safety interlock. As you all know, if you come to higher power lasers, they become dangerous. So you need safety interlocks. That means that you need relays, safety relays, e-stop buttons, whatever. Our power supplies have this system integrated. So you don't need external components anymore, like contactors or safety relays to operate your system in a safe way. Our systems are approved to the highest safety standards, so you can use it as a safety component. If you come to bigger laser systems, they're mostly water-cooled. So most of our power supplies are either water-cooled or baseplate-cooled, so that they integrate easily in the system. I have some examples of our systems. I go through it very quickly. If you want to have all the details, you can of course contact me. This is a typical power supply for fiber laser. With fiber lasers, you need a lot of smaller current sources because you cannot put your systems in parallel, because then in one system a lot of current is flowing and in the other hardly any. So each pumping diode or fiber needs his own current source. So in this case we have a 12 channel, up to 12 channel, and total 10 kilowatt. This is typically to make a 3 kilowatt laser. Of course, you can buy it smaller or even bigger to make more. Like I said, we have a safety interlock also integrated, so you don't need to have any external components. This is basically the thing you need from the mains input to your laser. A second system, it's more for diode bars. Diode bars typically needs one big source. So this is this example is a 21 kilowatt with integrated cooling. We can deliver it also in 7 and 14 kilowatt. And again, it has a safety interlock to eliminate the need of external safety components. This is a very flexible system, so we can configure it in different voltages and different current combinations. So for any high power application, we can supply you with a combination that suits you. Then finally, there also are a lot of customers that make their own drivers and so on, but they need a front end. If you buy a standard power supply, then and you go into pulse mode, then the lifetime of your power supply is probably very limited, because those power supplies are not built for pulse loads. These power supplies that we have are specially designed for the laser application. So if you do pulse loads of 1 hertz to 100 megahertz, it does not matter. It can handle these kinds of loads without having troubles with lifetime, overheating of your output filter. You can put them in parallel or in series, depending on how much power you need, how much voltage you need. And you can fully program it. So any voltage that you need, we can basically make. I hope I did it in about 6 minutes. I don't know. So that was my presentation. Of course, you can contact any time.
Thank you very much, Rene, for your contribution. So maybe we stop sharing. There you go.
Yeah. Okay.
So,
thank you.
Thank you. So as we said already, yeah, you are a bit on a high scale of power supply for this user. Maybe Andrea one day will want to go to get 300 watts, let's say. But I would like to say we have now soon the next series of events where we will talk about welding, we will talk about 3D printing. So yeah, if you want already give us a nuance of what these end users, so for you end users, for us mostly supply chain, so how you can supply the laser company with a bit higher power. Are you already in this market, so 3D printing in general, or in welding? I assume yes, but what is your expectation in this market for these users?
We see that the power levels go up all the time. If you saw 3 years ago, a big laser was 3 or 6 kilowatt. Now 20 kilowatt is I don't say normal, but not abnormal. Yeah, we are interesting, of course, to see where the market is going, and also in blue laser. If I see the applications there in welding and cutting copper, for instance, for the automotive and battery industry, I think this could be a huge market. And one of the questions you always ask, what can they do for us? We are very interested to see where the market is going, for instance, in blue laser. Not only on power levels, but what kind of voltage do they need? What kind of current? Rise and fall times? Do they need a lot of smaller modules? Do they need one big module? And that information for us is very important to know to develop something for the future. So I think companies like Naburo and other in higher power laser could help us with that, hopefully.
Very good. So someone was already talked on the floor. So Richard, do you want to say something? You're unmuted. Wait. Now you can speak.
Yeah, Rene, please feel free to contact me afterwards. I can put you in touch with the right people. In general, the demand, we started with 150 watts of blue power, and that the demand, there's virtually no demand for that anymore. It's moving up into the kilowatt regime. So we are now we're now at 1.5, and the same as the infrared industry developed in that way, so will we in the blue, but probably even faster, because there's probably more gains to be made in the efficiencies. So yeah, we'll definitely be looking for higher capacity power supplies. We work on a chip basis rather than a bar basis, but in terms of overall power, yes, we're moving from kilowatt output, from hundreds of watt output to multi-kilowatt output. So if you want to get in touch with me, I'll put you in touch with the right people at
we are already on speaking terms with your colleague Dennis, so
okay, great. Okay,
so but still it would be very interesting to get in touch to also see what the future will bring on a more technical level. So that's great.
Okay, give me a call.
Yeah, I will.
That sounds very good. Also, you were saying, Rene, you have maybe some concern about what the needs of the current manipulation that you should give in your power supply. There's someone who wants to comment on this directly, Richard, or someone else? Also for blue lasers, if there's some issue about it?
No, I have no, I have no knowledge about power supplies, apart from being electrocuted by them when I was a service engineer.
Okay, then it's not a good knowledge. We should avoid this kind of knowledges.
This was before health and safety became an issue.
Okay, no, this is, I guess, is a good point, but you know, it's really interesting to know that Rene is already in contact also with your colleague, and that anyway, as I said before, we will have also in the following series of events also something more interesting also on the welding and 3D printing side. So for sure, we will have Rene or some representative of PBF invited and honorably present in this meeting. We really look forward to it, and thank you for also coming here to a bit different audience. We like that people also engage in new markets, in possible new collaboration. It's good that also blue lasers is important for PBF. Now, do we have other questions for Rene or other general questions?
For Rene, no, but in general, I do have a question. I had some targets for this meeting, and all my targets were really to understand when it comes to the temperature stability of the laser diodes. Anthony from Glasgow, do you have some specifications on this? What kind of wavelength stability when it comes to temperature is currently designed? You work a lot with single frequency lasers. Anthony, I'm gonna unmute you in a second. We can hear you
from
now,
a
loud and clear.
Quantum applications point of view. Well, Chris probably knows better than I do. Blue lasers act very much like, in terms of stability and so on, and line width, act very much like their gallium arsenide or indium phosphide counterparts. We're actually just at the, blue DFBs haven't been available for that long, so we're still learning about the details of what actually affects the line width, and that's why it's interesting work, because it's A, it has an application, and B, it's not very well known. I guess from my perspective, when I'm hearing all of these enormous numbers being thrown about, like tens of watts and kilowatts and so on, I'm wondering what actually is just many stripes being combined together, and then powered accordingly, or what? Can someone explain to me how that works? For example, Richard, you mentioned a couple of kilowatts. I find that
I need to be unmuted.
Yeah, you are unmuted.
So, unfortunately, well, I like competition. We're not alone in the blue laser market, but we are unique in that we use individual diodes. So you take a wafer, you slice it and dice it. Other companies tend to use a bar with maybe something like 10 to 19 emitters, blue emitters on that bar. We take a different approach, and we use individual emitters, and we correct using micro optics for divergence in both directions and various other things, and then we do a load of beam combination and what have you. So it's two different approaches. You either start from singular emitters, or you start from a wide bar. And and the fundamental reason we do that is that we undoubtedly get a better beam quality out by correcting for individual emitters, which is something you can't do on a bar. You can't correct for the smile on a bar, or crosstalk between emitters on a bar. So that's the fundamental difference in blue laser technologies.
You have a few people, when you talk about micro optics, made their eyes a bit wider. I don't know if you noticed, but I did notice. What kind of micro optics do you use for the combination, for the manipulation with the beam?
Yeah, I can't tell you our sources, but they're They're very small optics, as you can imagine. They're designed to go right in front of the emitter, pretty close to the emitter, and we use robotic machinery to pick and place. It's not possible to do it by hand.
This is great. We should have started the meeting with you, because now
so we have a, we have a factory running now. There's nobody in it, and it's making lasers for us.
As soon as I can move, I will go and visit the factory. At Epic, we have actually put together the biggest worldwide supply chain of micro-optics manufacturing, combining roll-to-roll, 3D printing, roll-to-plate, and low-cost duplication. Actually, PowerPhotonic is one of the companies we have in the field of beam shaping using micro-optics. So it is great to have you that. And of course, we have also a very strong supply chain on automation for packaging with companies like Ficon Tech, like Amicra, like Erickson Tech, Fine Tech. Hello, all of you, I know you're watching. So I think we have a lot of room for collaboration. Just to remind you, we're going to have a meeting on micro-optics manufacturing, online technology meeting in a couple of weeks, and on Friday we have the online technology meeting in automation for manufacturing, packaging, and testing. So we're going to cover all your needs. With this, I think we have explored a lot of business opportunities. I think there is a lot of room to cover. There's a lot of collaboration. While you were talking, I was actually talking in the YouTube channel and at the same time making notes. So I'm multitasking, something that I actually can do quite well. Let me show you some of the notes I took during the meeting to see what you think. Because I really like when we organize this kind of meetings, not only to have fun, but also to tell people how the industry looks today. So one thing that I have, let me remove this. One thing that I have learned today is that we explore 3 application fields. We talk about the security and defense. It was the Chris when he told us about the quantum enabled. I love this word, Chris, because my PhD is in quantum physics, University of Bristol. So I love when people actually use quantum in different application fields. But you were actually talking about different wavelengths, and you talk about 100 milliwatts for the 461 nanometer, which was one of the key challenges. But we also see that you were looking all the way to the 4th harmonic on the 266 nanometers. The second thing came from ENEA and came not on the application that he was targeting, but there was a challenge on the radiation hard fibers that actually said, I really think that we can work on this. So I think there is obviously a key challenge, especially for the nuclear. You talk about the maritime, but you got a question about the nuclear, and that was obviously a beautiful challenge. And from Unity on the semicon market, the need for 10 to 100 kilohertz with less than 1 watt of power blue lasers. That was also something very interesting that we actually got to highlight on this slide. We talk about the beam shaping, and nobody could really give me like a big demand apart from a perfect Gaussian. I love that, so I put it in the slide. We want a perfect Gaussian. We want a perfect Gaussian everywhere.
No, Jose.
Yes.
I'm interested in external beam shaping for high power blue.
External beam shaping for high power blue. External beam shaping for high. Can you elaborate on that?
Yeah, as I say, Nuburu is a laser manufacturer. We don't integrate. So our customers, they want a beam shape. Sometimes they don't just want to focus it to a single spot. They may require different beam shapes. Depends what they're doing. We do much more than welding. So and these are components we don't plan on producing ourselves. So anyone producing external beam shaping optics for high power blue, I'm interested in.
I think Roy is also interested in that, helping you.
Hi, Richard. Yeah, PowerPhotonic do precisely that.
I know, Roy. I got your name here. I was going to.
Yeah, well, external beam shaping,
yeah.
And also you have to talk to OPI for the external beam shaping you do with the fiber as well. So there is some clear room for collaboration. And also on the packaging side, we talk about the fiber assembly, we talk about the optics and micro optics, we talk about temperature, and also for the increased power, which is a key challenge. We talk about in the individual emitters using micro optics, which is the approach of Nuburu, in comparison with the using of different bars. I think we have a comment from Guillaume from Unity. Is that correct?
Oh yeah, I just wanted to correct that we are not that demanding in line widths. The spectrum is more megahertz. Okay. Right, we don't go down to even 100 kilohertz.
All right. But I think we can really come up with the plan. The plan for me was really for you to find reasons of working together. And I think that was very well achieved. USHIO, there's many people who want to talk to you, Ardan, on this. There's, of course, Comtech on the 3.5 on the passivation. You have a clear link there with TopGaN laser. I think you have to talk about that. Anthony, you've been a star today. I'm really looking forward to have the meeting in Glasgow in September. I hope the situation normalizes by then. Andrea, you are great, and OPI is fantastic. The collaboration that you have with many of the high power laser manufacturers is something that we have been looking at, and I hope to have you soon giving a presentation on the EPIC meeting on industrial lasers at Convergent in the beautiful Torino. PowerPhotonic, Roy, these axicons are revolutionizing the world. Keep bringing freeform optics, my passion, keep bringing freeform optics for the laser world. Seiya, Roy is going to buy some coatings from you. We need your coatings, reliability and lifetime. That's what you provide. And the laser from Barcelona, from Monochrome, you guys are doing a fantastic job, an amazing job. We talk in different events on the way that you actually reduce the smile factor with your different way of manufacturing the lasers. This has been fantastic. Richard, you're a star. Whenever you bring to a meeting, you bring value to the different companies. It was great to have you. The same thing as with Guillaume from Unity, talking about the semiconductor market. For Chris and for Luigi, it was your first ever EPIC meeting. I'm very interested in what you thought of this. Chris, what did you think about the meeting?
We're fighting each other on the mute button.
Yes.
No, it was great. It was enlightening to kind of see what other applications are out there and what people are looking for. It was eye-opening to me.
Luigi.
Yes, so it's been a great meeting. First time for me. I am a newcomers, but I discovered a lot of new possibilities for my institute, a lot of new possible collaboration, a lot of new ideas. So I'm very happy. Thank you again for inviting me.
And thank you very much, all of you, for attending this meeting. I think I would like just to remind everyone in the YouTube universe who have watched this live and who are going to watch it later, if you want to contact any of the participants of the meeting, all you have to do is contact me, jose.pozo@epic-asoc.com, and we'll be happy to make that introduction one-to-one. The same goes for the participants of the meeting. You don't know each other's email addresses, just have to contact me, and I will make sure you get introduced in a way of making sure that everybody keeps being connected, that everybody uses EPIC, that everybody is EPIC. Until the next time, it was a pleasure spending the afternoon with you. Keep busy, keep healthy, stay at home, and watch all the live streams of EPIC. See you soon. Bye-bye.
Okay, bye-bye.
Bye. Thank you.
Thanks for organizing.